I've always thought of Calico as the networking project that plays nice with everything. But they really shook things up by bringing eBPF into the mix with version 3.13. What made them decide eBPF was the way forward?
Honestly, eBPF is like a Swiss Army knife for the Linux kernel. Calico saw how it could run mini programs right inside the kernel, cutting out the back and forth between user space and the kernel that slows things down. That's a big win for speed and flexibility.
It's wild how far eBPF has come. It started as a tool for packet filtering, but now it's doing everything from tracing syscalls to enforcing security to, apparently, routing network packets at lightning speed.
Exactly, and Calico's whole philosophy has always been pick the best tool for the job. eBPF lets them update the data plane logic almost on the fly, which was tough with traditional iptables or BGP setups. That agility is game-changing for modern cloud environments.
That makes me wonder, out of all the ways to use eBPF, why did the Calico team settle on TC hooks instead of something like XDP or socket-based processing?
Well, there was a lot of internal debate. XDP is blazingly fast, but it's tricky. Hardware compatibility can be a pain, and it's not as mature across all environments. The TC hooks, on the other hand, offer a sweet spot, early packet processing that works consistently on more systems.
That's true. Sometimes the fastest technology isn't the most practical, especially for a project that needs to run everywhere. And I heard they also looked at tables, but it didn't quite keep up with iptables in their testing.
Right, and their main priority was not to break the user experience or the Calico policy model. So, sticking with something robust and mature, like TC-eBPF, let them innovate without leaving users behind.
Switching gears a bit, I'm fascinated by how they re-implemented kubeproxy using eBPF. That's a bold move. What kind of improvements did that bring?
Latency reduction was a huge one. With classic kube proxy and iptables, service latency scales up quickly as you add more services. The eBPF approach keeps things snappy. Even as clusters grow, it shaves off half a millisecond or more in some tests.
That's no small feat. Saving CPU cycles per packet and reducing hops for external client traffic, those optimizations add up, especially in high-traffic environments.
And let's not forget source IP preservation. With eBPF, Calico can keep the original client IP intact through node port and cluster IP scenarios. That's a lifesaver for logging and compliance.
Still, I have to ask, what's holding the eBPF data plane back from being production-ready right now?
A few big things. Security gaps are being ironed out, and there's no IPv6 support yet. The fixed MTU requirement is another headache. Plus, you're stuck with newer kernels. Anything below 5.3 is out of luck.
So it's really for enthusiasts and early testers at the moment. I imagine that's why they call it a tech preview and are still working on feature completeness.
You got it. Some Calico features don't work in eBPF mode yet, but the groundwork is there. They're really encouraging community feedback right now to help surface odd bugs and edge cases.
That actually reminds me, debugging eBPF sounds tricky. How are developers supposed to troubleshoot issues in this new data plane?
There are some internal tools to dump state and debug eBPF programs. You can crank up the logging, but it's a bit like drinking from a fire hose, so much data. They're planning more selective logging to make it manageable.
And for folks curious about jumping in or giving feedback, Calico's community sounds pretty active. GitHub, Slack, Twitter, you name it.
Absolutely. And the project's open source roots mean anyone can pitch in, whether it's bug reports, feature requests, or just testing. The next big steps are rounding out IPv6, dynamic MTU, and getting ready for general availability in both open source and enterprise releases.